RDD. RDD stands for Resilient Distributed Dataset. RDD stands for Resilient Distributed Dataset. Resilient Distributed Dataset. So whenever you are creating RDD, this RDD automatically distributed based on the number of partitions you created. It will distributed according to the partitions. Okay, first one. And second one, what is resilient? What is resilient? Distributed, we know. Your data stores in across the cluster, right? Distributed data set means data. And what about resilient? What is resilient? See, we have file 1 with 600 MB. We have a file 1 with 600 MB. For this file, we have 5 blocks. For this file, we have 5 blocks. 5 blocks. So, whenever you load this file into RDD, for each equivalent block, it will create partition. For each equivalent block, it will create partition. Assume this partition 3 is failed. Partition 3 is failed. If partition 3 is failed, it will recreate. It will recreate automatically based on data. Already data is presented, right, in a block, HDFS block. Data is presented in HDFS block. So what will happen partition level? If partition is failed, it will recreate automatically based on existed data available. Based on existed data is available. Okay. So this recreation is called resilient. Resilient. If RDD is removed or failed, it will recreate automatically. It will recreate automatically. This is called resilient. Resilient. Example, I'm loading file 1. We have 5 partitions. So I'm exporting transformation on first partition. First data, we are applying transformation. I will get Y RDD, right? I will get Y RDD. So what is happened for Y RDD? So when we create an RDD, automatically file first X RDD contain 5 partitions, right? Again we are creating Y RDD. So based on your transformation, it will create for each partition equivalent partition is created. For Y RDD, equivalent partitions are created. If X RDD contain 5 partitions, for Y RDD also it will create 5 partitions. 5 partitions. Next, on Y RDD, I executed transformation 3. So it is created Z RDD. For Z RDD, input is Y RDD. So Y RDD, how many partitions Y RDD has, those many partitions is created for Z RDD. On Z RDD, I applied again one more transformation. So I got A RDD. On A RDD, I am executing action 1. So here observe one important point. First one, we are loading file into RDD X. From RDD X, we created RDD Y. From RDD Y, we created Z RDD. From Z RDD, we created A RDD. Right? From all these steps, data is not created. Memory is not allocated. From all above steps, data is not allocated. Because for transformations, memory is not allocated. Then what will happen? So we are saying what? some transformations. I'm saying when you apply any transformation, internally memory is not allocated. Then what will happen for these transformations? What will happen for this transformation? What will happen for these transformations? For all these transformations, internally, Spark creates one graph. What is the graph name? I think previous classes we discussed this one. What is that graph name? Can anyone tell me the name? Yep, some more advanced. This is correct. The tag is correct. Some more advanced one. You came near to that graph name. Lineage graph. Yes, you are correct. Lineage graph. So internally, Spark will create lineage graph. Lineage graph. That lineage graph contains this sequence of flow. Whenever we apply action, A1 means action. Whenever we apply action, DAG, DAG means direct acyclic graph, executes this lineage graph. Executes this lineage graph. First, it loads file into XRDD. From XRDD, it will create a transformation. From YRDD, it execute transformation. From ZRDD, it will execute transformation. And finally, it will execute this action. Once action is completed, once action is completed, it will remove all the memory. It will remove partitions, whatever the partitions is created, right? All the partitions are automatically removed. All the partitions are automatically removed. So once action is executed successfully, once action returns, yeah, we'll discuss what is persisted later, Ravi. No worries. So here just we are executing one by one. We have very important concept of persisted. So Ravi said that what is persisted. We are going to discuss that concept. What is persisted and how to persist RDD. We'll discuss that concept later, Ravi. Next class, maybe next class. Okay. So once action is executed, once action is executed, it will create, it will execute that entire flow. Then finally action is successfully executed. This entire memory, whatever the memory is allocated, right? That will remove automatically. That will remove automatically. So Spark application by default delete partition immediately after result is generated. Okay. Again, if you execute one more action, again if you execute one more action, then again it will start from this location to this location. Assume this Z transformation is using multiple times. Z transformation is using multiple times. Then instead of executing from start to end, we can persist RDDs. We can persist RDDs. We can persist RDDs. We can persist RDDs in memory. What is the advantage of persisting? It will not execute from beginning. It will execute only from this one. ZRDD is persisted, right? So on ZRDD, it will execute this transformation and next action 3 or action 4. If you execute action 5, again it will start from Z transformation, ZRDD transformation. That is already ARDD is persisted. So it will not execute above all steps. It will return action only from that RDD. So what is the advantage of this approach? If any RDD frequently using, if any RDD frequently using, then we can save that RDD into memory so that we can avoid execution of flow from beginning. So that we can avoid execution of flow from beginning. So it will save multiple transformations. It will save multiple transformations. Ultimately, if it saves a number of transformations means ultimately it will improve performance of your application. Performance of your application. Okay. So what is resilience and what is persistence? What is resilience and what is persistence? Resilience means if any partition is removed, if any partition is removed, that partition automatically recreates. That partition automatically recreates. Persistence means we can save RDD sometime. We can save RDD into a memory sometime or permanently so that we can avoid executing from beginning to that RDD. So it will improve performance of application. So you got the point, right? What is resilience and what is persistent? So the ability of regeneration of lost partition is called resilience. The ability of preserving the output of transformation into memory or hard disk or later use is called persistence. Persistence can reduce the efforts of regeneration of lost partitions. If the partitions are lost, this issue is taken care by Spark engine. Spark engine. So if the node is down, then issue is taken care by cluster manager. Partition is lost, it is taken care by Spark engine. Node is down, this is taken care by cluster manager. So if it is a cluster manager, resource manager is responsible to taken care. If this is cluster manager is Mesos manager is responsible to resolve this issue. If cluster manager is standalone, Spark master is taken care to resolve this issue. Okay. As a Spark developer, if partition is lost, we cannot do any things manually. If partition is lost, automatically it will recreate. Automatically it will recreate. It will recreate. So that is called persistence. Sorry, resilient. Persistent SIM means we can save or we can store RDD states. Assume we are executing multiple transformations. Each transformation returns some RDD. Instead of executing from beginning to end, we can save or we can persist RDD sometime or permanently into memory. Okay. So once you persist, then it will reduce number of efforts. So instead of starting from beginning, it will execute from that persisted RDD. It will save number of operations. Okay. So you got the point, right? What is persistence? RDD can be persisted in memory or RDD in serialized or deserialized mode. And with replication, without replication. I said resilience means if any partition is lost, if any partition is lost, it automatically recreates partition because data is available in disk, right? So if any partition is lost, it automatically recreates partition. That is called resilience. RDD main advantage is if RDD is removed from memory, it automatically recreates. How it recreates? Data is already existed in disk. HDFS or local storage, any file system already existed, right? So it will automatically recreate. So that concept is called resilience. What is persistence? Anyone? What is persistence? What is persistence? Saving the RDD state, right? Regeneration of last partition is called persistence. Regeneration of last persistence is called resilience. Regeneration of last partition is called resilience. What about persistence? What about persistence? Saving the state of RDD, right? Saving the state of RDD. What is the advantage of saving the state of RDD? So RDD means how RDD is created by loading file and by performing any transformations, right? If you apply any transformation, it will generate another RDD. Yes or no? If you perform any transformation, it will generate RDD. So if you load file, if you perform any transformation, internally it will manage lineage graph. By default, it will not create memories in RAM. When memory is allocated, when memory is allocated, whenever we perform action, right? Whenever we perform an action, it executes from file loading to all transformations. Yes or no? Assume one transformation is using multiple times. One transformation is using multiple times. So for that one, instead of starting from loading file to all the transformation to up to that transfer RDD, what we do, we save that one. We save that RDD so that it will reduce loading file, performing transformation until that required RDD. We are saving that RDD state so that it will not execute above flow. It directly uses this RDD data. So to save transformations or to save time, then we go for what? Persisting RDD. Persisting RDD. So persistence. First, the ability of regeneration of last partition is called resilience. The ability of preserving the output of transformation. The ability of preserving the output of transformation into the memory or hard disk or for later use. For later use is called persistence. So you got the point, right? What is the difference between RDD and persistence? What is the difference between resilience and RDD? Okay. Next, persistence can reduce the efforts of regeneration of last partition. If you persist RDD, if any, if that RDD is lost, we have already saved data, so it will reduce loss of partitions. This is one. Next one, the if the partitions are lost, issue is taken care by Spark engine, right? If any partition is failed or lost, that is taken care by whom? Spark engine. If the node is down, that is taken care by cluster manager. So as a Spark developer or Spark engine is not responsible. If mission is down, cluster mission is down, that is taken care by cluster manager. Okay.